I'm in the mood. So we can talk a little bit about yourself for the behavioral part. I could almost like Google common behavioral questions if you're in the mood for that kind of questions.
Yeah, sure. I think that'd be pretty good because the like tell me about yourself question's kind of broad. So I mean,
Yeah,
I'm pretty
it's
bad at I'm pretty bad at behavioral questions. Not gonna lie, I don't really prepare that much for them, but I find that that's like my main weakness in my interviews. So I think that'd be helpful.
okay. Okay. Well, I think tell me about yourself is like such a lazy question by the interviewer, but it's one that you're gonna get. So you better be ready for it.
Yeah, yeah, for sure.
So tell me a bit about yourself.
Sure. So I'll just give you a little bit of background on my schooling and also my experience in some projects that I worked on. So I just recently graduated from the University of Waterloo from the computer science program. I got my Bachelor of Math from there back in April. Um, and some of my experience includes two internships, both at SAP and GE or General Electric. So both of those positions were just mainly DevOps positions. It was just like working with the cloud, or like writing automation scripts in Bash and Python, and just doing just general monitoring of the servers and fixing issues as they come up. Um, and as for my projects, I just created a few projects. So one of my projects is a Nintendo 64 game. So it's just a remake of a shareware game called Bow and Arrow for Windows 95. I just recreated it from scratch on the Nintendo 64, and it's on GitHub. It's on YouTube, so if you search my name, you can find it.
Yeah, I think I
Yeah,
saw it, and it actually runs on the Nintendo 64.
yeah, it does.
Oh,
And I tested it on real hardware.
that's not
Uh,
your game. It's just bow and arrow and Google.
no, I'll send the YouTube. Actually, hold on a second. If you search my name, my full name, Nathan Duma, you'll find it.
It's
Someone
linked
made
on
it.
your binary search as well.
Yeah, I can't find it on YouTube. Just give me a sec. I know someone posted it, but I don't know if they removed the video. There you go. Oh, I sent it to you on Discord. You can look at the
All right.
yeah. If you just want to take a quick like 2 seconds, just look
Yeah,
at
yeah.
that.
I want to see it. Oh wow.
So some people may have saw the game before.
Wow.
Um, well, yeah, the first part's glitched, but it's because they ran in an
Man, the
emulator.
sprite. Did you draw it yourself?
The Nintendo 64 logo?
Not the go the
No, no,
archer.
no. No, it's actually a remake. So like I pulled the images from the
Oh,
actual Windows 95 game and I just mimicked everything like as the original game would play.
okay, okay.
Yeah.
Damn, that's sick.
Yeah, yeah. It was a lot of work because I didn't have a debugger. So I had to basically print stuff to the screen, and if it crashed before printing stuff to the screen, then tough luck. I had to figure it out manually. So it took a lot of time, but I was able to finish it. So I'm pretty proud of that. Pretty
Man,
happy.
sick. How do you even code for the Nintendo 64? Is there like do you code in C or
Yeah, yeah, it's coded in C. You can code it in assembly too, but most people don't. So there's actually a Nintendo 64 SDK, which actually just comes with like the basic stuff, like like um how to like run the different threads, like the audio thread, the video thread, and like all that. And then you basically can just use that to just communicate with the Nintendo 64 to put stuff on the screen. So
man, that's
yeah,
epic, man.
it's a lot involved, but it's pretty interesting.
Cool,
Yeah.
man. Cool. Anything else?
I created some other projects, like just some simple automation projects. So like I made a Kijiji reposter with Selenium and Java. I also made another. It's not on my GitHub, unfortunately, but
Okay.
I made another one. There's a gym called Fit for Less that I go to. You have to book time slots during these times, so I just made a bot using Selenium to just snipe the times when someone gives up their time, so I can get a gym slot. So, so like I love automation. That's why I went into DevOps, and I'm still continuing to do so. So
Oh, that's it. That's it.
yeah.
All right, 7 o'clock. It is time.
Time. Let's do this.
Hell yeah. So the question for today is. I'm gonna put it in comments here. You probably heard of it before, but we care about your performance and not about the code.
Sure.
Spiral matrix. So, given a matrix of n by n elements, so m rows and n columns, return all elements of the matrix in spiral order. So, what do we mean by spiral order? So, I think the best way to illustrate this is with examples. Is basically you start from the top left, so on the one here, and you just follow the edges like this. So you go to the right, then down, to the left, up, until you meet a position that you've already seen before, and you keep turning right. So for this example, it would be 1, 2, 3, 6, 9, 8, 7, and 4, 5. So if you want another example, I have one here. So same logic. It would be 1, 2, 3, 4, now down, 8, 12, now left, 11, 10, 9, up to 5, and finally right, 6, 7. So this is your final output. Do you have any questions?
So it's an m times n. Okay, yeah. Just trying to think. Can we have an empty matrix?
Yeah, you can.
Okay. Empty, and then let's see. M times n returns all the elements in spiral order. Okay, so. I'm just trying to think. No, I don't have any questions.
Okay.
Yeah, so I'm just gonna go. Just trying to think. Right. Okay, so this is an interesting problem. So like I have a few approaches that I'm thinking about. The first approach is when you take, you start at the top left corner, and then you recursively go to the right, and then you go down, and then like if you hit a wall, you just switch direction, basically.
What do you mean by recursive?
So basically, like I just I start at 1, and then I just call the function again to go right, and then once you can't go right anymore, it goes down, and then if you can't go down anymore, it goes left, and then it goes up, and then I would also have like a second double array, which is the places that we visited before, and then if we visited, then we just return as well, and if actually, wait, would that even work? I have to think about this. Just give me a moment.
I think it potentially could work.
Yeah, it potentially could work.
But I think it's like overly complicated to try to represent it in a recursive fashion.
Yeah, it is. So I think like the iterative approach will probably be easier. But I'm just trying to think like how I would iterate over those indices. So say we start at the top left, and then we have a function. We have 4 functions that either go up, down, left, or right. So we can have like a switch statement to go to switch the direction. Like if we hit a wall, like as I said, if we hit the wall on the right, then we go down, and then if we go down, we go left. I'm just trying to think if like there's an easier way, because I don't. There could be like a mathematical formula for this as well, for those loops to just.
Oh, to find like the indices.
No, just to switch the direction. But I'm just trying to think like.
Oh yeah, like rotate 90 degrees to the right, basically.
Yeah, pretty much. Just to think. Which one? 8, 4, 12. Okay, so I'm just gonna use the example that we have, and I'm just gonna write out the indices to see if I can find some sort of pattern.
Okay.
So yeah. So the indices would be let's see, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and then
Actually, I think it stops at 0, 3.
oh wait, sorry, where does it start? Doesn't it start at 0, 0?
Yeah, but it ends at 0, 3.
Oh, sorry, yeah, you're right. Right, my bad. Yeah, so go down there, and then we would just go 3, 1, 1, 2, 3, and then that's it. Then we go to the next line. It would be 2, 3, 1, 2. No, sorry, it would be 3 and 2, 3 and 1, and then 3 and 0. And we go up 1. So then it'd be 2 and 0. And then we have 3 more. So it's just going to be 2 and 1. 2 and 1. 2 and 2, and then 2 and 3. Sorry, 1. Sorry, it's not 3. Wait a second.
Oh, yeah, I think it's here. Yeah.
Yeah, it's 2 and 3. Should be 2, 2, and there should be 1.
But here you're counting 2, 3 twice.
Wait, yeah, my bad. I'm just trying to. Yeah, sorry. Should be 2. No, sorry, it's it should be 2. Should be 2. There you go. Let's see the kind of a pattern. So if we have ij, then so I 0, j is j goes up, and then j stays the same, and then we alternate between so we alternate that. Alternate incrementing the I and j once we switch a direction. And then on this one we start decrementing j. And then this one we start to decrement I as well. So we kind of have a thing where if we go if we go right, increment j, and then if we go down, then we increment I, keep I the same, keep j the same, and then if we go left, then we increment j, keep the same, and then if we go up, then we decrement I and then keep j the same. And then we have a cycle. So right, if we reach the wall on the right, then we go down, then we go, and then if we reach the wall, we go left, and then we go up, and then we just keep repeating that.
Mm-hmm.
So basically, what we want is we want to have some sort of way, like two variables, one to see which value we switch, so either I or J. And then for the second one, we either want, we need to know whether we should decrement or increment the variable. And basically, if we go back up here, right, down, left, up, we would do, we would need to modify J, and then we need to modify I, and we need to modify J and I, and then so on. Mm-hmm. So we need some way to do that. So we have those two variables. And then we would just have a while loop, and then what we would do is we would just decrement. We would need to perform the increment or decrement operation on the correct variable, and then we need a case where we need to stop. So we need to stop at either we touched a wall, and in that case we switch the direction, or in the second case we have a hash map. That has the I and J values. And then this will indicate that we also need to just switch the direction. Okay. Mm-hmm. So yeah. So like we found it, like, so say like we went, we got in the example above, we have 1, 2, 3, and 4. Then we switch direction 8 and 12, and then we switch the direction 11, 10, and 9. We switch the direction 5, and then we didn't hit a wall. Like, we went upwards, but we hit a 1. So then we basically just change the direction from the 5, and we go right and get the rest of the numbers. So that's the goal of using the hash map there. Yeah. Does that approach make sense? Yeah. Do you think that's like a reasonable approach?
Yeah, it's just making sure for the hash map you're storing the coordinates, not the value, right?
Yeah. Okay. Of course, the I and J values. Yeah.
Okay.
So the I and J values.
Yeah, makes sense to me.
Okay, I'm gonna start implementing that. So we need to. I'm gonna do this using namespace standard library, and then we need to include a map, and we also need to include vector, because that's our input. Do we need anything else? No, I don't think so. So I'm gonna start writing the function. So what is it? Spiral. I'll just write a test case for this just really quickly. Okay. Oh yeah, we also need to return the function. I mean the vector. So this is the return value. Okay, just do this, and then I'll just make the output for it. Okay. All right, so this will just output the test case. I'm going to make the function called spiral, so it's just going to be the spiral function. Matrix, and then we're going to do, we just need a matrix, and I'm passing it by reference just because I want to copy it. Okay. Memory, yeah. So we just need to make our spiral flat. actually we'll just call it return. So this is the vector that we're going to return. This is just going to be the spiral, the flattened spiral we're returning. So so going back above, we need to have two variables. So we need one to which value to switch, and also we need one to know if we should increment or decrement. So since we're switching it every other iteration for I and j, we're just going to have just a simple boolean. What is it called? What should we call it? Switch var false, and then false means we're going to start it on. Actually, no, true. We're going to start it on. What do we start it on? J. Start it on J, and then for the decrementing, so that happens every single 4 cycles. So sorry, there's a cycle of 4. So basically, we just want a value to determine. I'm just going to use a simple int, and the values of 0 to 3 would say if we need to increment or actually wait a second. Yeah. The value would be to increment or decrement. So 0 and 1 would be to increment, and then 2 and 3 would be to decrement. So I'll just use a simple int for that. Int decrement equals 0. And we're just going to modulo for it every single time we add 1 to it. So we're going to have the I and j. So int I equals 0 and j equals 0. Okay. And then what we want to do is when should the while loop? Oh yeah, we also need the map as well. So map int. This is just going to be the values that we. Sorry, it's going to be, what is it? A set. So set. Wait, we use set of pairs. So we're instead of using a hash map, we're just going to use the set. Okay.
Yeah.
Include set, and then the set will just include the values that we visited as a pair. So just the I and j value. Okay. And we're just gonna make a while loop now to go through this. So basically, what we want to do is I'm gonna set up the if statements. So we have the things up here. We have to check each iteration if we hit a wall, or what is it? So either we hit a wall or it's inside. It's it's a value that we have seen before. So we're going to do a simple wall check. So the wall check would be if I is greater than or equal to I is greater than or equal to the matrix at dot size. Yeah, the matrix dot size, or j is greater than or equal to. No, I think we need to separate them, right? Because if we reach just one moment.
Yeah, no problem.
Yeah, I think we should do the checks first, and then afterwards we implement the values. So we need to check. This is just to switch the direction. Okay, matrix 0 dot size, and if either of those fail, so that means that we're out of bounds, or we saw the value before. So what's the so it's visited dot find make I and j. Not equal. So we found it. We visited already. So then what we want to do is switch the direction. So it's gonna do. Well, let me just. This line's kind of long. Hold on, wait. Why doesn't this work? All right. Anyways, I'll fix the error later. So direction plus equals 1. Actually, no. Direction equals 1 plus 1 mod 4. Okay, so we're doing mod 4 just because.
Is that your decrement variable or?
Sorry, yeah. Sorry, yeah. Decrement. That's what I meant. Sorry, not direction. No, wait. Yes, yeah, it is. And then I think I have to separate this actually, because if we go over on, like, if we're out of bounds on the I variable, then what we need to do is let's just see. Just 1 second. Yeah, let's just separate them because I'm not sure how it would pan out in the end.
So what's the difference between the two cases?
Well, the difference is that if we visited it, then what we need to do is we actually have to decrement the value due to, or wait, I just need to think of the two cases. So if we go out of bounds, then what we have to do is we have to switch the direction, and then we also have to bring back whatever variable went out of bounds back in bounds. So like subtract by 1. So we have to separate the I and j case there. But if we also visited it, we also need to do the same thing. So I think you have to separate these. So if the I1 goes out of bounds, then what we want to do is we need to subtract I by 1 to make it go back in bounds. And
But that depends on your direction, right?
yes, but we're incrementing. So like at the end of the function, what we do is like we do we just do.
I think that's an overly complicated way to deal with the direction, to be frank.
Yeah, I think so too. I'm not sure. I'm just trying to think like how I would do that. So like I can just have like a simple
Like there's 4 directions, right?
yeah.
Could you just store the 4 directions and do each of them? Yeah, do each of them sequentially.
I mean, I could put it as an enum if that's what you're getting at.
I mean, what do you do at each turn depending on the direction?
You just either you decrement or increment.
Yeah, right.
Yeah, but you have to like do like one. You have to do it every. You switch the increment and decrement every 2 operations you do, or like sorry, every 2 direction switches.
Yeah, but you could use a negative value, right?
Oh right, yeah, you could actually. Wait, but you still have to have 4 directions. Like you would have like -1 and 0.
Yeah.
Oh, I see what you mean. So like if it's I'm just trying to think about that. So like if you have like negative, well, you can't have -0, so you have to use like -1 and negative. I mean, yeah, it's kind of complicated, but I'll stick with it because I'm not sure how to do it unless you can give me another hint because I didn't really.
Yeah, because I'm kind of afraid if that you'll get lost with it, because I'm lost with your way of dealing with things, and I think it can get complicated really fast.
Yeah, for sure.
So basically, what I think could be a good idea is like to store the delta for each direction. So when you're going right, you have like a delta of 0 on the I coordinate, because each turn you don't move on the I axis, I mean.
Oh, okay. I see what you mean. Okay,
Yeah.
yeah. Yeah. I think I got it. What you're saying. Okay, so basically, you just have a vector and directions. Okay, and then you store each of the directions. Just one sec. Yeah. So when we're going right, we're going to increment j by 1. Okay, so this is what you're saying. Like you just have a you just do a delta on each pair. So like we just like switch the direction and then we just go to the next one.
Yeah.
I see. Yeah. That makes sense. Compare. So if we're going right, then we do j plus plus, and then we also increment I. So it's just going to be 1 and 0, and then for that one we go backwards. So 0 and -1, and then make pair 0 -1 0. Okay. Int direction 0, and then it's just mod 4, and then we can just keep incrementing the direction. Okay, I see what you're saying. So we need to have a thing. So if I is greater than or equal to dot size. So we went out of bounds on the I. Then we switch the direction. So the direction plus plus, and then we also have to decrement I here because we went too fast. So I plus equals.
So instead of like undoing your move, basically you're gonna have to like have a special case for every direction, right? Or like if your I is greater than the matrix, you have to reduce the I and then do the same thing for like every side of the matrix. Instead of like undoing the move, could you like think of a simpler way to avoid like enumerating each case?
Yeah, I could. So instead of that, we can just have a statement before it just to check if that's some. Well, yeah, like you would just check like if the I plus 1 would be able to bounds or j plus 1 be able to bounds, and then if not, then we increment it.
Yeah, sounds good.
And then we and if not, then we have to switch the direction.
Mm-hmm.
Yeah. So if I plus 1 is that size, then we can just do this. Otherwise, we just have to switch the direction. Direction plus plus. Yeah. Same thing here. J. Let me just do it for J. X 0 dot size J direction plus plus dot second. Yeah, this should be dot second. Now then we can avoid this check overall. And then okay, so after we increment it, we actually need to just input these in the visited. So mark that we visited this element.
There's maybe one small thing. What happens if like we're going left and we go out of bounds?
If we go left, oh right, that's a good point. Oh wait, oh yeah, because it's not actually. Okay, yeah, we need to actually implement this as well. So like we have to add the direction that it's actually going in to get it. So like if we're going left, this would be negative, and then because like if J was so if J was 0, then it would and we're going left, then it would be 0 plus -1, which is -1. Oh, but that would also pass it. Okay, yeah, I see. Let's see. Next I is equal to this. Right. So we have to check if it's within the bounds as well as so greater than 0. Next I is greater than 0 as well.
Yeah.
Yeah, and then we have next J as well. Next J. It have to be equal to this because we just modified it. So it's J, and next J is greater than or equal to 0. It has to be greater than or equal to 0, right?
Yeah.
Okay, so we have that, and then we have the direction. Okay, and then we just mark it that it's visited, and then we just need an if statement in the very beginning to check if we actually already. No, wait. No, we have to mark the current one that we're on. Yes, so. Yeah, so like if we're on 0, 0, we make a pair, we put 0, 0 back in. And then once we go around in a spiral, we hit 0, 0 again. So we need something to check if it exists or not. So we actually need to check if visited dot find make pair I and J. So we actually need to check like if it's actually inside there. Visited. So like we need to check if we actually visited it, and if we visited it, then all we have to do is we need to switch the direction. So direction plus plus plus. And then once we switch the direction, we just keep going until the end, and then we actually need a if statement to break. So
what happens if like basically what I understand is that you end up on a cell that you visited already. So let's say you did the first loop and you end up at 0, 0 once again. So when you get there, you check if the current position is visited, and if so, you just rotate.
1 second. J. Can you repeat that, please? Like
Yeah.
we rotate.
So let's say we reach the first position after doing the spiral around the matrix. So
Yeah.
we reach this position and now we check if it's been seen before. And if so, we just keep rotating.
We rotate that and wait a second. So I check if we visit like okay, yeah, we rotate it. Oh no, then my code wouldn't work then because we need to check that if we okay, so yeah, we change the I and J, and then we need to check if it's actually inside before we change it. We can't make any changes. Oh, this is interesting because I'm updating. I'm computing the next location after I put it in the array. So I need some way to check that if the next location is something that we visited already, then we actually need to switch the direction. So Yeah, I need to put this code afterwards. And then the switching of the direction, when we just mark that we found it, it has to be hold on, I just have to think more about this. Okay, so I'm just gonna go back to the example. So like say we started at 1, then we would check if it's inside. If not, insert it. We inserted it. We got the direction, and then once we hit a wall, it changes the direction. But then, so it works fine for those cases. But then once we hit the 0, 0 again, so we computed the next I and j. We're at 0, 0, but we need to revert. We basically shouldn't go to. Okay, yeah, so I'm just going to put this up here. So we compute the next I, and then we compute the next j.
Mm-hmm.
If and then yeah, we input we try to find if the next I and the next j isn't actually inside the visited one, and if it is, then we actually have to reset the next I and the next j, and we also have to change the direction of it. So the next I would be equal to next j. Yeah, so we basically change the direction. We change the direction, and then we compute the next iteration after that. And then afterwards, we check if we need to go if it's in the bounds, and also if we need to switch direction.
So there's something here I wanted to point out. Is here you're doing next j. I think
Oh
here
yeah,
you
sorry.
write
Yeah.
next I, and like here you do direction plus plus, and I'm curious if it's possible to like go into both of these if statements.
Oh, that's actually a good point. We have to check if both I and j are fine. If not, then we have to actually switch it. Let's see. That's a good point. So the simple case is we have I and j, they're both in bounds. That's good. Yeah, it's possible, like, because you can change the direction twice, right?
Mm.
Say we're out of bounds. Wait a second. If we're out of bounds, then we stay on that I, and then we switch the direction. But then if the j is out of, I don't think there will be ever a case where the both I and the both j are out of bounds, just because like we only have like 0 and 1, 1 and 0, 0, -1, -1 and 0 for the deltas.
Mm-hmm.
So it would never do that. So I don't see the issue there.
Okay.
Yeah. I'm not sure if this will work, just because I'm just. So I'm trying to do the found case. Like, we computed the I and the j. We found the pair that it existed. So then. So then what we do is we switch the direction, and then we recompute the direction, the next I and the next j, the next iteration. And that should always be inside it. And then there's actually a thing. So like I made the while loop, infinite while loop. The second, I think the way to end the while loop is that if I check if we visited the next node as well, then that means we should break out of the loop. I think it's kind of like ugly to code it this way, but that might be the end condition for this. Which is, yeah, it's not a good way of coding it. And I'm not sure if the code will work. Can I run it? Do you mind if I run it?
You can try.
Okay. I'll probably get a bunch of syntax errors, but we'll see.
Yeah, it's fine.
Okay, 1, 2, 3, 4. Let's see. 1, 2, 3, 4,
Maybe
4.
add some spaces with the.
Oh, right. Sorry, my bad. Okay. I think it's kind of close. Let's see. 1, 2, 3, 4, 4, 8, 12, 12, 11, 10, 9, 9, 5. Wait, 9, 9, 5, 6, 7. So it works, but it's just double counting the edges. Yeah. Let's see this.
Because basically you switch the directions, but each time you switch the directions, but you like do another run of the loop, right?
Yeah.
So you insert it like twice.
It's interesting. Let me just see. So like I insert that, and then it's time to switch the direction. So then the J went out of bounds. So then we do. And so next I is good. So we switch the I. But wait, if we switch the I, oh no, because like we didn't switch the direction beforehand. Right. Okay, I see. I see what we did. So I'm just gonna basically just have two things here. We're just gonna check if we went out of bounds on either of them. Okay, and then if we did, then what we want to do is we just want to recompute the I and J. So we just do direction plus plus, and then we do this, and then we can just get rid of this whole if statement right here and just set the next I and next J.
Sounds good.
I think that should work. Missing a bracket, or missing that. 0. Seg fault? Okay, great. XJIJ. It's probably because of this. It's out of bounds when I compute the next I and the next J. But where is it faulting? Let me just I'll put before. Oops. Seg fault. I'm not sure what's happening. Check 0.size. Okay. So it should access the directions vector just fine. I'm pretty sure it's just out of bounds error with I and J. So I'll leave that in and I'll just do this. And then this should just be.
Yeah, because printing the value at I and J won't help you to know if you're out of bound, because it's gonna segfault when you're trying to read the matrix, right?
I think it should be nothing outputted. Oh, it has to be not. 1 second. Oh, wait a second. If it's in bounds. Okay, so basically we go 1500. Yeah, it's definitely going out of bounds somewhere for some reason. J plus directions. I'll revert to what I had before. Zero. Yeah, it's probably seg fault because it's free. It froze. Oh no, infinite loop. It's infinite loop. I think I can just get rid of this, just the direction part, because like what I think is happening is just it needs to do the out of bounds check because we recompute the I and J value, and we want to keep it the same if it goes out of bounds, just because like, we're modifying the other variable, the other I or other J. So I'm just gonna check if this works. Will this ever?
Yeah, I'm curious where it gets stuck right now.
Yeah.
If only there was a way to find out.
Okay, infinite loop. So starting at 5, 1, 2, 6, 5, 1, 2, 5, 6, 1, 5, 2, 6. Yeah, it's just going in. It's just repeating itself.
1, 2, 6, 5, 1, 2, 6, 5. Okay.
Yeah.
It's turning in circles.
Okay, I see. So it checks the direction. It's just a problem with this if statement. Let's try to figure this out. So first we compute the next I and the next J iteration.
So why do you have two ifs basically? Because you check if the next value is not visited, you're like, okay, the next. Actually, you check if it's visited, you do a rotation.
Yeah.
You check if it's out of bound, you do a rotation.
Yeah, but we don't really. Wait a second. What if we just did this? I don't know how to clear the screen. I have to type clear. 1 second. Clear. Okay. Yeah, infinite loop again. Let's see. Okay, now it's just printing one value for. Oh no, we have to. Sorry, we didn't. We computed the next value, but we never switched the direction. Oh, because it's getting stuck on the 4 because I never switched the direction, so we have to have a direction switch. I'll just go back on what I had before. So I can just go back on that. So the reason why we have the two if statements, the reason why we have the first one is we need to check if it's visited, and then we have to do a recalculation on I and J. And then if we do that recalculation and then we find that it's inside, then we just we break. So we just return the vector. Let's just see.
I mean, here you're checking that it's within bounds, right?
Yeah, it's within the bounds.
So if it's within the bounds, you do.
So sorry, my bad. It has to be if it's not in the bounds.
Okay.
If it's out of bounds, then we have to recalculate. Okay, yeah, that makes sense. Wait. Okay. If it's not in the bounds, then we have to do a recalculation. Yeah. Yeah, it's going out of bounds. So we just check if. Oh crap! I need another parenthesis. I need another bracket. There we go. So we need to get the whole statement. So we check if it's in bounds. If it's not in bounds, then we have to change the direction and we recalculate it.
Oh boy.
Oh, C++ can be fun, right?
Yeah.
Where is it going wrong? Oh boy.
So is it still going in circles?
No, it's not. It's just it's going out of bounds because I can tell like it's just random garbage values. So I never checked if the new calculated value would be out of bounds though. So like if I had like what I had before plus the parenthesis, would that work? Because I didn't test that. Okay, it gets stuck on 4 still. So that means it got to the end, it went from left to right, and then it couldn't switch the direction. Oh, sorry. This has to be an and because we're checking if it's in the bounds, and then it's not. We're checking the negation of that. Okay, now it works. So let's just run that again and see is it the correct answer.
So 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, 7. Yeah, that's the correct answer for that test case.
Yeah.
So, do you have any idea of edge cases you could test?
Yeah, I do. So just one where it's like a perfect n times n, just because once you reach the middle, like I don't know how my program will handle it because like mine just like n times. Basically, it would switch the direction if it visited something. I think it would still work though. So like if it's a square matrix, I'll just try like if it's just a square, it should print 1, 2, 3, 7, 11, 10, 9, 5, and 6. So let's just try that. 1, 2, 3, 7, 11, 10, 9, 5, 6. So I think like that's like one edge case. Another one would be an empty matrix.
Mm-hmm.
I don't know if that would work. Let's just see if it works for empty. Probably does because it won't. No, actually, no, it doesn't because it's infinite loop. So we actually have we need to have an if statement actually. Equals 0, then we return nothing. Yeah, we just return an empty vector. So we have that case. The second case I can think of is just one single element. I think that would fail too, actually, just because I need to test that out. So like let's just try like one single element in there. Yeah, and it's an infinite loop as well.
So why?
And I think it would fail also if it's just one line. Yes, it would. So those are some edge cases as well. So like the first edge case would just be having one row only, whether it has like one or more elements. That's also an edge case.
Yeah.
Yeah.
That's good. So there's like 4 minutes left. One last thing, like I'm not sure if 4 minutes is enough to fix the edge cases. So maybe like, could you tell me about the time complexity of your algorithm and the space complexity?
Sure. So the space complexity, So we're storing the directions as O of 1. We just have 4 times 1, so it's just O of 1. And then we have the list of pairs. So visited. It would be n squared since there's n squared pairs of I and j,
Mm-hmm.
and n squared elements. And then that's it for the space complexity. Oh no, and actually it's n squared plus n because we also need to store the result as well.
Yeah,
Yeah.
well,
Anyways.
you can ignore the smaller power of n, I think.
Okay. Yeah. For sure. Yeah. So just n squared. As for the algorithm itself, it's actually n squared because we're visiting every element at most once. And the reason why is because when we check if we visited the value, the pair I and j before, then like we're only visiting it once, and there's n squared elements, n times n, so it's the algorithm's n squared, and then it will terminate yes.
Okay, yeah, that's good. Just a small detail. You probably have to use the variables from the problem statement. So instead of saying n squared, it's probably better to say m by n because
Oh
the
right, yeah,
dimensions can
right.
vary. Like it's a small
Yeah,
detail that they pretty much mean the same idea, but
yeah. I mean, I just simplified it just because the worst case is we have n times n, because m could be like one, and like n plus one, or bigger.
yeah,
So like just take the bigger one. Yeah.
yeah, fair.
Yeah. And then just one thing of how to fix my issues. So the first one was just the empty bracket. Sorry, the empty matrix. So I just created like a simple if statement for that up here. The second thing is also we need to we also need to have a second case as well. If the matrix dot size of like if the first row is sorry if the amount of rows is just one, then what we want to do is we just want to return the first row. That's it.
Yeah, that would fix that specific case, but I think it would still break if you had just one column and
Yeah. I was actually thinking of that too. One column as well. Actually, wait, would it break because it was switching the direction to right? I have to test that too. Yeah. That's actually another test case I forgot about. No, it's an infinite loop. Yeah, so I have to fix that as well.
yeah, don't worry too much about it. It's like depending how if you do it on a whiteboard or whatever, like small typos and whatever don't matter. But like I'll tell you what I like. The first part I really liked is how like before jumping into the code that you like broke every step down like and wrote a comment for everything and like every single detail was like explained thoroughly. So that was really good. Like I was really into it.
I see. Thank you.
So yeah, that was good, and I think that makes sense. The part where I was thinking it was weird, like not necessarily wrong. The part where with the like variable for decrementing and incrementing and knowing which variable that you have to switch. I think that's just like a question of like coding style and maybe like experience and how to like handle those kinds of things. But I wasn't sure if I should like let you try your way because it sounded really complicated and like you had to basically handle every case 4 times for like every direction and then know how to switch correctly. So I think that's just experience that will give you like a normal coding style of like handling standard things like that, I'd say.
Yeah. I definitely agree with that. Like I thought it was a little complicated as well, but then once you mentioned the deltas, I was like, oh yeah, I remember doing that before. So it was a good hint.
Yeah.
Yeah.
So I think that's okay. Like I would give you that hint and it would be fine. Like it's just a weird reflex to like come up with a super complicated solution to do that thing.
Yeah,
Yeah.
of course.
So yeah, coding style was weird. Like I wasn't sure during your implementation why you like separated like the handling of visiting, like trying to visit a square that has already been visited and trying to visit a square that is out of bounds. Like I think that is like a code smell somehow. Like basically you want to make your code as clean as possible during an interview, So I think you could have just merged both ifs and like check if the next square is valid instead of like handling a visited square and out of bounds squares differently. So I think if you did that, the code would have been a lot simpler, and like you wouldn't have as many bugs and problems trying to get to a working solution. So I think the main issue is like coding style. I'd say like the
Yeah,
logic,
for sure.
the explanation, the communication, everything is great, but the coding style is a little bit off, I'd say.
Okay, I see. It's good feedback. I definitely agree with it. Like it could be a lot more clear, but I just didn't know how to separate those two cases. It was just kind of weird.
Mm.
But I need definitely need more practice with that for sure.
Like it's a weird question because you can't really like categorize it like a DP question or like any other type of like standard question. It's more like a ad hoc question where you really have to like improvise because there's not really any other problem like it. So it
Mm.
really like puts into evidence your coding style and just like your raw coding ability because there's no really complex algorithm. It's basically you turn in circles and you have to like understand that if you rotate 2 times and you're still stuck, then you have to stop, otherwise you're gonna go back on the path you already saw.
Yeah.
There's also another trick you can use is check the length of the return vector, and you know basically that there's going to be as many elements in the input matrix as the output matrix, so you know you can stop if the, let's say your matrix is n by m, you
Yeah.
know if the output vector is, if it's of length n by m itself, then you know you can stop. So that's another insight you could like find maybe. And there's also a way of doing it in constant space, but I think it's a little bit more tricky. So instead of like storing every single position, you don't really need to know every single position. You just need to know like the limit from the top, the right, the bottom, and the left part. So you can have 4 variables that denote like the limit. Like at the start, it begins at like the limit at the top is like index 0, and then at the right it's like the right limit, that bottom, and then the left is 0 as well.
Oh, I see.
And
Yeah,
then you
that's pretty
like
fun.
you can iterate until you reach the limit, and then you like reduce the limit by 1. So you keep turning like that, and it's gonna end up in a spiral. But there's like so many edge cases to handle that if I were to have this question in an interview, I probably would go with the n squared or n by m space solution because it's more intuitive. Like you can just check the next step locally to see if it's valid, and if it's valid, just go ahead, and it's way simpler that in that fashion. And I think like in an interview you could like make the decision of like taking a less optimal approach in terms of like space complexity, whatever. But if you have like a good justification like this, like you say, okay, but well, I'm ready to give the trade-off of like giving a bigger space complexity, but in return I'm gonna get like a simpler code, something that's easier to maintain. So you can like find arguments outside of the pure algorithmic sense of like problem solving. You can say, okay, well, it's better code design, like it's more maintainable. So try to like pull off your engineering hat more than the like computer science side of things.
I see. I see. Okay.
So yeah, that's a big rant. So I can show like the solution that is like constant space and whatever. You just have like 4 for loops, and there's like another trick that if like the top part is like greater or equal to the bottom, or the left part is greater or equal to the right, it means like you're currently iterating over one dimension, so you don't need to do the left and up part. So like it's really weird. You don't really like want to get all into all those details because like it's just a bunch of off by ones, and it's not really fun to handle with in an interview. So I think I'd recommend sticking with the solution you came up with, just
I
like
see.
refining the coding style, trying to make it more reusable and more clean. I think like your variable names are fine, but yeah, I think it's just like practice. But it's hard to like practice that specific kind of question, so you just need to like have better habits.
Yeah, for sure. That's something I'll definitely work on. I just find that like with binary search, you're really pressured to do the question like within the time limit really quickly. So like I'm just used to writing like just a bunch of dirty code. I guess that's not the way to go. So I'll just definitely like focus on slowing down, just writing more clean and elegant code. But yeah, it's good feedback.
Yeah, you have a little bit more time in an interview, but yeah, you have to be careful because since you like take time to explain and everything, like it goes back by really fast. But
Yeah,
it's a
for sure.
balance, like everything. Like you don't want to spend too much time, like all the time, focusing on refactoring or whatever, but you want to spend some time, I think, and you want to show like insight that you care about the quality of the code and you want to like make sure that you're not like shipping some non quality code, I'd say.
But is it just better to just get the solution first and then maybe tidy up the code later? Because like I've noticed in some interviews, they just ask me maybe like to tidy up the code in the end, like if I can make things simpler, and they suggest things. Um, like would you rather just like get the solution out there first, or would you rather have like pretty code and it not working?
So
Which one would be better in your opinion?
so it depends on the it can depend on the interviewer. So like some interviewers might care less on the coding style if it ends up working, but I think like if you don't care, there's more chance to that there will be bugs, so it might end up hurting you more than anything else. And like I think,
Uh,
like I said with Bunny earlier, like the time investment that you put into making sure everything is like well bundled into function that have like significant names and that you can reuse. I think like
okay,
it's easy to get lost, like even in just 1 hour of coding, like if you just put stuff everywhere and you start copy pasting, like it's just gonna hurt you more than anything else. And it really doesn't take that much time to refactor, like at least a little bit, like make sure things make sense are where they're supposed to be.
I see. I see.
But yeah,
All
if
right.
if you're gonna make like something that doesn't work but it's pretty, like yeah, for sure you're not gonna get a job if you don't do the work that is asked. Because yeah, there's balance with technical depth and everything in real life. So yeah, that's a thing.
I see. Yeah, for sure.
Like you can say, oh, I would test like more edge cases. Like you can name a few, but I won't spend too much time on that because we are like constrained by time right now. But I would in real life say something like that. Like just say that you care and you would do that in real life, but like that you have like your priorities. Like, you just have to justify yourself to the interviewer. So like it shows your thought patterns, like how you think and how you
Yeah.
would do the job. So he has like good reviews to give you to the hiring manager basically.
Yeah.
So there's no like binary answer. Like some interviewers might like not really care about the coding styles, some just want like to see if you pass. Like I don't really know like how all interviewers do their interviews, but I think like if I was to hire someone, I want someone that cares about the quality because like that's how code bases survive in the long run.
Yeah, but like, would you say like a coding assessment in an interview would be appropriate to look at that rather like, or would you think like looking at like previous code on their GitHub would be more valuable?
For sure, the like looking at the projects is important, but like to be honest, like the algorithms that you build like in a interview, like if you know that specific question, like you're just gonna like shoot it out like in a few minutes, but like it doesn't really matter that specific algorithm that you figure out, or if you know like that specific way of solving a problem, if you have like good good coding style and good like way to break down problems, I think that's more important because
I see. I see. Okay, makes sense.
there's like a lot of people just memorizing a bunch of solutions nowadays. I feel like with leak code and everything, it's just like grinding, but it doesn't show like how you actually do work in real life. So yeah, maybe looking at projects can be a better indicator than just like a 1 hour interview. So
Yeah, for sure.
yeah, so it's complicated. Like there's no clear answer in my mind either, but I'm just trying to like find what's the best things to focus on. And I think like it has some value. Like writing quality code has some value, at least in my mind.
Hmm.
That it's a personal choice. If you manage to like nail your coding interviews writing like unreadable code with like one letter variables, then good for you. It's
Or a
possible.
bunch of one-liners.
Yeah, exactly. I don't know. Maybe it's possible.
Yeah.
So, what did you think of the experience?
Okay, so at first I was like pretty nervous, and then in the middle I was like pretty nervous as well because like I just couldn't think of like what to put in the while loop. And honestly, like during coding interviews, like I just try to like write what I can in the time that we have, but um I just don't want to leave like an awkward spot where like I'm not saying anything for like a couple minutes because I'm thinking about the problem because like you're supposed to be speaking out loud, so I try to speak out loud as much as possible.
Yeah,
But definitely, like I think the pre-planning of the question helped, like the write-up I did before the first part. So
yeah,
overall, I think it went fine. But the corner cases, like I didn't really think about that when I was writing it. I probably should think about the corner cases in the beginning as well in the write-up, which I'll probably do for next time. But um, overall, I think it went okay.
yeah. Like test-driven development in an interview is pretty OP if you have the chance to run the code. Like just having a bunch of test cases and writing the smallest function you can and basically get some code running as soon as possible. It's just like such a good confidence booster, and like it helps you while you develop on the long run as well.
Yeah, and then outputting as well. Like I haven't done any like physical interviews before. Actually, I did like one physical interview before, but like all of them were remote, and I was able to run my code, so that was pretty easy for me.
Okay, okay.
But yeah, I'm not sure about like the whiteboard style.
Yeah, I did one on a piece of paper, and it's not fun.
Yeah, like
It's
I can imagine.
yeah, it's more of a discussion. Like exactly, the code doesn't even matter. It's more like how you think, how you approach the problem, like the questions you ask. It's really like trying to see what kind of engineer you are.
Yeah, yeah, for sure.
It's like the problem is more an excuse to see how you think. Yeah, and about like getting stuck and not knowing like what to say, I'd say like maybe try asking questions to the interviewer, asking for hints. Like I think it's a good thing knowing when you're stuck and that you need to get some help, because that happens in real life as well. Like sometimes you like don't know all the things you need to know to be able to move forward. So you're like put in a situation that okay, I could try to figure it out by myself for like a few days and try to impress my coworkers, or I could go seek help. And I think like it's almost more honorable to like admit some defeat sometimes, like ask some help and almost treat your interviewer like your coworker. So like just start a discussion. Okay, so I'm thinking about this, but I'm not sure like how it would work in this case and how we could approach this, and I'm not sure if this is the best way of doing this. Like, I feel like there's something better I could do, but I'm not sure what. And like, almost try to like bait the interviewer into giving like his opinion, so you can like steal hints from him. Try to social engineer the interviewer, basically.
Yeah, if you get on the good side, they'll answer your questions, but sometimes they just won't. I've had that happen before both ways, so
Oh yeah. Okay.
yeah.
Well, if your interviewer is not in a good mood, well, sometimes you just get unlucky as well. So
Yeah,
you
yeah.
just have to
Oh,
try your luck and do the best of your situation.
yeah, yeah, for sure. I
Yeah.
mean, I mean, it's not possible to win them all, but
Yeah.
yeah. So
Well, thank you for coming, man. It's been a pleasure and an honor of interviewing another Waterloo student.
thanks. I feel like I got roasted pretty, pretty
Yeah.
badly. I don't, I didn't keep up with the chat